Hey everyone, in this video we will be officially starting our learning of the SQL language, and we will be implementing some things using the SQL language. So let's see what we will be doing today. We will at first be taking a look at some of the key points regarding SQL, followed by some different things like how we can create a new user using SQL, how we can create tables, how we can do some commands using the select, insert, and drop statements, and finally, we will be taking a look at primary keys and how they function in SQL. Towards the end of the video, we will be taking a look at some of the tips and tricks which you can use to make your life easier when working with SQL. Right? So let's begin. The first thing is some key points regarding SQL. Right? So as you might know, SQL stands for Structured Query Language. Okay? It is a special type of language which is used to query information from relational databases like Oracle, MySQL, PostgreSQL, and so on. One of the most important things that you need to remember when working with SQL is that it is not case sensitive. All right. So what do I mean by that? So imagine I have a table, or let's see, I have a table like this. All right. And suppose in this table, I have two columns, ID and name. Now, when working with SQL, it doesn't matter whether I write down the column name ID like this or like this. That is, it doesn't matter whether I am writing down the names in uppercase or lowercase. Similarly, it doesn't matter if the name column is written in lowercase letters like this, or if it is written in a mixture of uppercase and lowercase letters like this. All right, all of them are the same when it comes to SQL. So all the keywords and all the column names, all the table names, all the usernames that are used in SQL are not case sensitive. However, the values that you insert under these columns are definitely case sensitive. All right. So suppose under this name column, I have inserted a value that is my name, like this, where the first character is in uppercase and the rest of the characters are in lowercase. All right. So what you need to remember is this name is not the same as this name. All right. These two are separate when it comes to SQL. So what you need to remember is the keywords and the column names and the table names and the usernames and so on that are used inside SQL language are not case sensitive, but the values that you insert or you see inside under the columns of the SQL tables, all of those are definitely case sensitive. Okay. Moving on. After the key points about SQL, let's see what we have to do when it comes to creating a new user using SQL inside the Oracle database. So far we have only seen the system user in our previous two videos, right? So from this video, we will be working with some non-system users, all right? And the reason we actually create new users or non-system users is because whenever we actually want to do some basic or general database operations, we do not want the system user to be handling all those general database operations, right? System user is not for that. We want to create a new kind of user who wants to, I guess, work with some tables or manipulate entries inside those tables and so on, right? So we need to know how to exactly create new users. Now, whenever we want to create a new user, there is a sequence of operations that we need to follow. Let's take a look at those. So at first, we have to log in as the system user, all right? After logging in as the system user, we can issue some commands to create a new user with a password. And finally, we can grant some permissions to that new user so that he can do some basic operations in the database. All right. Now, when I talk about permissions or privileges, there are a lot of different kinds of privileges that you can grant to the new users. All right. So some of the privileges that we will be taking a look at in this lecture is the create session privilege, the resource privilege, the table space privilege, and the DBA privilege. Now, the create session privilege allows the new user to actually log in into the database. All right, so this is very important if you actually want to be able to use that new user in your database. The next privilege is the resource privilege, and this privilege allows the new user to actually create and manipulate tables. So this is also very important. The third privilege we will be taking a look at is the table space privilege. Now, this table space privilege grants the new user actual permissions, and basically it allocates some system memory to the user so that the user can actually create and store tables in our memory or in our storage. Okay, so that's what this table space permission is for. And finally, we have the DBA privilege. And the DBA privilege, as you can already guess, is admin level privilege. And obviously, we should not be granting the DBA privilege to a new user, okay? Because DBA privilege is very important and it should not be granted to any random user that we see. And so in this video, we will be creating a new user, but we will only be granting the first three permissions or privileges, that is the session, resource, and table space privilege. All right. Now let's take a look at the syntax that we need to follow whenever we actually want to create a new user. Now, remember when I said that SQL language is not case sensitive? Well, for easier understanding, throughout this video, what we are going to do is we are going to write down all the keywords of SQL in uppercase letters and all the non-keywords in lowercase letters. Okay, so that will make things easier to understand when learning the SQL language. So let's see. For creating a new user, the syntax is very simple. We simply write create user, where both of these two are keywords, followed by the username that we want to assign to that new user, followed by identified by. Again, these two are keywords. And finally, the password is going to be anything that we want to assign as the password for that user. All right. Next, we have to grant some specific permissions or privileges to that user. Now, it is possible to grant multiple privileges or permissions at once to the new user, or if we want, we can grant one privilege after another as well. Now, if we want to grant multiple privileges at once to the new user, what we do is we simply write grant, followed by the name of the privileges separated by a comma, and then to username, where username is the name of the user, obviously. So let's create a new user in our SQL command prompt. Now, at first, if you remember, we have to log in as the system user, right? So we will write connect system, and we are specifying that we will be using our pluggable database, followed by our system password. And there we are now connected. So let's create a new user, okay? Create user, followed by the name of the user that I want to create. So suppose for this video, I will be creating a user called test user, and then identified by, and then we have to write down the password or write down a password for this new user. So suppose for this user, I want to assign the password pw123. All right, great. The user has now been successfully created, but now we have to grant this user sufficient privileges so that he can actually work inside that database, right? So the first permission that we are going to assign is the create session privilege, grant create session. And this privilege will allow the user to actually log in into our database, all right? And then another permission that we are going to assign to him is the resource privilege, which will basically allow the user to create and manipulate tables inside our database, okay? To our test user. Now here you can see that we have gotten an error, and this error is happening because we had a typo. So we wrote a grant create, but it will be grant create, all right? So yeah. Now we can see that we have successfully granted these two privileges to our new user. But notice that we have not granted the table space privilege yet, which means that we have not assigned this user any permission to use the disk space in our system to actually create tables. And so now we are going to grant the table space privilege by writing down this command: grant unlimited table space to test user. There. Now the user has enough memory to actually create tables in our system. So we wrote unlimited here because we want no limits for now for this new user to be able to create tables. All right. If needed, we can also specify a limited amount of memory, but we will not be taking a look at that for now. So anyway, after we have successfully created this new user, it is now time to actually log in as this user, right? So let's disconnect from our system account there. And finally, we can connect as our new user. So we will write connect followed by the name of the new user. And then we will specify the pluggable database name followed by the password, which was PW123. There. Now that we are connected as this test user, let's see if our permissions are working. All right, so we will go ahead and create some tables. Now, when it comes to creating tables using SQL, the syntax again is actually very simple. We have a create table. These two keywords are very important, followed by the name that we want to assign to that table. And then we have a parenthesis. Now, inside this parenthesis, we have to define the column names as well as the data types of those columns that we are creating. All right, so let's take a look at this dummy table that we had created earlier. In this table, you can see that we have two columns, right? We have the ID column and we have the name column. Now, intuitively, we can obviously understand that this ID column is going to store numbers or integer type variables, right? On the other hand, this name column is going to store string type values, right? So whenever we want to create a table like this, we have to specify the column name as well as the data type of that column, all right, in SQL. And so for this lab, what we are going to do is we are going to take a look at two special types of data types, varchar2 and int. There are obviously a lot of other different kinds of data types when it comes to SQL, but for this lab only, we are only going to be taking a look at these two data types, right? So varchar2 is the string equivalent in SQL. All right, so in languages like C++ or Java, we have a data type called string. That data type is basically called varchar2 in SQL. Okay. Now, whenever we write varchar2, you notice that we also have to specify a number inside a parenthesis, right? This number stands for the length of the string that we will be inserting inside this column. All right. So if I write something like varchar2 30, what this means is that we will not be able to insert any string value under this name column that exceeds the character count 30. All right. So all the values that we can insert under this name column has to be within the 30 character count limit. Okay, that's what this n stands for, or this number 30 stands for. Okay. Next, we have int, which basically stands for integer values. All right. So let's go ahead and create some tables. Now, whenever we write commands like this, or big commands like this in SQL, we do not exactly want to write down these commands directly into the SQL console, because one of the biggest disadvantages in SQL console is that we cannot backtrack our writing, right? So if we have some kind of typo in our writing, we cannot go back and edit that typing. We have to write down the whole thing all over again. So what we're going to do is, at first we are going to write down the commands inside a notepad file, and then we are going to copy and paste those commands inside the SQL console. Now, obviously, you might be wondering why exactly we are not using any kind of IDE to complete our tasks. The reason for that is because by not using IDEs, we want to accustom ourselves to the syntax of the SQL statement a bit more better. Okay. So we are not going to be using IDEs for our labs. We are directly going to be using Notepad and the SQL console so that we can easily accustom ourselves to the SQL language. All right, so let's go ahead and create a table. So imagine we want to create this student table. Okay, now inside the student table, you can see that we have three columns: ID, name, and semester, right? So let's go ahead and create this table. So the command for creating this table is very simple. We will simply write create table followed by the name of our table, which is in this case student, and then we will have our parenthesis followed by name of those columns, right? So the first column name is ID, And then we can obviously understand that this ID column will store integer values, right? So after writing down the name of the column, we write down the data type, so int. So let me write the int in uppercase letters. Now int is a keyword in SQL. So to understand it better, I have simply written it using uppercase letters. It is also going to be the same if you write it like this in lowercase letters, but for easier understanding, as I have mentioned earlier, we are going to be writing down the keywords using uppercase letters. Okay. Next, we will have a comma, and the comma indicates that we have more columns that we want to include in this table. All right. So id int, comma, and then we will write name followed by the data type, in this case varchar2. Now suppose I want to limit the name character count to 20. Okay. So whenever we actually insert any values under the name column, we cannot insert any value which exceeds the 20 character count limit. All right. Another comma, and then we have semester. So let's see, semester followed by again varchar2, and here we will limit the character count to 5. All right. And since we do not have any more columns, we are not going to use any comma. We are simply going to end our parenthesis and then give a semicolon. So now we are going to copy this command into our SQL console. There. So table has been successfully created. Now, after creating this table, it is obviously natural for us to want to see what is exactly inside this table, right? Now, if we want to see what exactly is present inside this table, we have to use the select statement. All right. And the syntax for the select statement is also very simple. As you can see from here, we simply have to write select star from table name, where table name is the name of our table. Select and from are both the keywords in this statement. Okay. And the star stands for all. So whenever we write star, we are essentially defining that we want to see the values of all the columns and all the rows inside this table. Okay, so the star stands for all columns in this case. Just remember it like that. So let's see what happens whenever we execute this command inside our SQL console. Select star from student. Okay, you see that we are getting a message that says no rows selected. Now this is happening because we don't exactly have any entry under this table now, do we? And for that reason, we are not getting any values whenever we actually execute this query. Okay, and so now we are going to take a look at how to insert values inside this table of ours. Okay, so let's go ahead. All right, we are going to take a look at the insert into statement. Now, when it comes to SQL, there are mainly two ways you can insert values inside the table. All right, so the first way is like this, where the statement is insert into table name followed by the values keyword, and inside the parenthesis we insert a value for each column that we have inside that table. Now in this case we have 3 columns, right? ID, name, and semester. So if we want to use this statement, we have to give 3 values inside the parenthesis, 1 for each of those columns. All right, so let's go ahead and insert some values using this insert into table name statement. Okay, so insert into student values, and then in parentheses, let's say the ID is going to be 1, the name is going to be Anas, and the semester is going to be 4th. Okay, now notice that whenever we are indicating integer values, we are not using any quotation mark. However, whenever we are inserting any string value or varchar value, we have to use single quotation marks. Okay, in languages like C++ or Java, we used to use double quotation marks, but in case of SQL, whenever we insert any string value or varchar value, we have to use single quotation marks. Okay, so remember that. And there, 1 row has been created. Great. Now let's see what happens when we execute that select statement again. Okay, so now you can see that we have a table called student where we have 3 columns, ID, name, semester. I guess I have made a typo in the name here, but it doesn't matter. And then we have one row where the ID is 1, the name is Anas, and semester is 4th. Okay. Now let's take a look at the second insert into statement that we can also use for creating entries inside the table. In this specific command, what we can do is we can specify the column names inside which we are trying to assign values. Okay, so suppose I want to insert a new entry inside this table, and that entry does not have any student name but only contains the student ID and the semester. Okay, so the way I can do that is by specifying that I only want to insert values under the ID column and under the semester column. Okay, so let's see how we can do that. Let's write down that statement. We can write insert into student, and then we will specify the column names under which we want to assign the values. So I only want to assign values under the ID column and the semester column. So I think I have written semester as semester, so that's what I'm going to write here. Semester followed by values, and then the actual values which we want to assign. So let's say the ID is 2 and the semester value is 5th. Okay, there. One row created. So now again, let's see what entries we have under this table. Okay, so when we write select star from student now, as you can see, we have created a new entry where the name is missing, but we have the ID value and the semester value. Okay, so the advantage of using this select insert statement is that if we want, we can circumvent some specific columns under which we do not have any under which we do not want to assign any value. All right, now we have already taken a look at the select statement, right? So the select statement is used to basically query all the information that is present inside our table. And we have also stated that the star is used to indicate all columns. That is, whenever we actually write star, we are mentioning that we want to see the values of all the columns, right? Now, what if we want to see the values of some specific columns? What if we want to only see the values of the ID and semester column of this table? In that case, what we have to do is we simply write select, and instead of star, we write down the name of the column names. So ID, comma, semester. From student. So doing it like this is going to make sure that we only get values for the ID column and the semester column. So there, you can see that right now the table is only showing us the ID and semester value. Okay, so in this way, if we want, we can query information from specific columns instead of all the columns. Also, the select statement can be modified by using where clauses and order by clauses and many other clauses, so that we can get some specific rows instead of all the rows inside that table. Okay, but for this lab, we are not going to take a look at those. We are only going to work with the simple statements here. Okay. Next, let's move on to the drop table statement. Now, the drop table statement, as you can probably already understand, is used to delete any table from our database. Okay. Now, remember, whenever we actually use this drop table statement, it actually deletes all the information that is present inside that table as well. So you need to be very careful whenever you actually work with this drop table statement. Okay, so as you can see, the syntax for the drop table statement is very simple. You write drop table followed by the name of the table that you want to delete. Okay, so let's see. Suppose we will be dropping the student table. Drop table student. Okay, there, the table has been dropped. And now let's see what happens when we try to execute a select query on that table. We can see that we are getting an error that says that table or view does not exist, which means that the student table has been successfully deleted from our database. Now we will be moving on to the last topic for this lab session, which is working with primary keys. Now, when we work with any table, sometimes it might be necessary that we want to uniquely identify each entry inside that table, right? So if we go back to our dummy table here, you can see that we have two columns, right? ID and name. Now, what if I want to see the information related to student number, student with ID 2, right? So suppose I have two students here, a student with ID 2 and a student with ID 4. Now, what happens if I want to uniquely identify the entry with the student with ID 2? What I can do is I can use this ID number 2 to uniquely identify that, okay, the row with the student ID 2 has the information like name is Anas, and if there are any other columns, we can say that those informations are also present inside this column, inside this row, right? Similarly, if we want, we can also mention that the student with ID number 4 has this name, and if we have more columns here, we can say that those informations are also related to the student with ID number 4. All right. So basically what I'm trying to get at is primary keys can be used to uniquely identify each row in any specific table. All right. Now, you cannot exactly make any column as the primary key. All right. A column can only be a primary key only if it has unique values under it, right? So suppose if I had another entry inside this ID column like this, so basically if another student had the same ID as this student here, then it would not be possible to uniquely identify that student using this ID column, right? Because both of them have the same ID, and so we would not be able to uniquely identify that student using this ID column. So in that case, we would have needed some other some other special column which contains only unique values for each of the students, right? So in this case, for this sample example here, we cannot use the ID column as the primary key because two students have the same ID. Okay. Anyway, when in SQL, whenever we actually want to define a primary key for our table, we have to define it while actually create the table. Okay. Now it is also possible to add a primary key later to a pre-existing table by using the alter table command. However, in this lab, we are not going to be taking a look at the alter table command, and so we are going to define our primary key while actually creating the table. So let's create the table here. Again, let's use the notepad. So this is the advantage of notepad, right? We can simply edit some of the things inside the notepad and again copy and paste them directly into the console. So anyway, the syntax for creating a primary key is actually very simple. Whenever we actually create any table like this, towards the end of the parenthesis, that is right before ending the parenthesis, we write down primary key, followed by a parenthesis inside which we define the name of the column which we want to declare as the primary key. Now, whenever we actually create any primary key like this, notice that we also have a comma before the immediate last column name. In this case, semester is the name of the column, which is basically the last column before the primary key. So what we're doing here is we are giving a comma after semester here, and then we are writing down primary key, right? So all we have to do is give a comma here, followed by primary key, and then in parentheses, define ID as our primary key. Okay, let's fix that typo here and there. So when we execute this command inside our SQL console, you will notice that this ID column has been successfully defined as the primary key. So let me show you. Okay, great. The table has been created. Now, how do we check that our primary key is working? Now, remember, this declaration of the ID column as the primary key is a constraint that we are setting on this table. Okay, this is very important. I will repeat it again. Whenever we actually write down this command, we are defining a constraint that says that the ID column is the primary key for the student table, which means that we will not be able to insert duplicate values under the ID column for this table. Okay, so let's add a dummy data inside this student table. Insert into student values 1. Let's write down the name as John, and let's write down the semester as third. Okay. One row created. Now when we execute a select query on this table, we are getting the dummy entry that we have just created. Now again, let's insert another dummy data, but this time we are going to use the same ID again. Okay, that is 1, but the values for the rest of the columns are going to be different. So let's say the name is going to be Alex, and the name of the semester is going to be second. Okay, this is also a good opportunity to show you something. So if you remember, I have mentioned that the values inside of the column are going to be case sensitive, right? So let's say I'm going to write down the semester like this, where N and D are in uppercase letters. So anyway, you will notice that in this case, we have a second entry here where the ID value is the same for our entry, right? For our student Alex. But if our constraint is working properly, that is, if our primary key constraint is working properly, then the SQL console should give us an error when trying to insert this value. So let's see if we get that error. So yeah, as you can see, we are getting a constraint, which is saying that unique constraint, then the name of the constraint is testuser.sys something something, violated. Okay, so we can say that our primary key constraint is successfully working. All right, now instead of inserting 1, what happens if we insert some other value, which is 2? So this should work because the value 2 as the ID does not exist inside the student table anymore, right? So if we do it, you can see that we get one row created. And now if we execute the select statement again, you can see we have 2 entries where the first student has ID 1 and the second student has ID 2. So basically we can say that our primary key is working. And again, for the semester value, as you can see, since we had used uppercase letters for the semester value, that uppercase value has been maintained here. So basically, any value inside the columns are case sensitive, but the SQL keywords and the SQL commands themselves are not case sensitive. All right. So those are the things that I wanted to show you in this lab session. Now, there are a few tips and tricks that you can use to make your life easier when working with SQL. So for example, you can use the show user command to show the username of the currently logged in user. So if I write show user here you can see that the currently logged in user is test user. Okay. And when we want to log out of our SQL session, we can simply write disk or disconnect, and then it will log us out of our system. Now, sometimes you might come across this error, which is basically caused by different issues, but basically what happens is you are locked out of a specific user account. That is, you cannot log in into a specific user account, even if you have the right username password combination. In such cases, what you have to do is you have to log in into your database as the system database admin, that is sysdba, and then you have to issue this command where you are basically altering that specific user's account by unlocking it. Okay, so you can issue this command and that user will be unlocked and can be used to log in into your database again. Now, sometimes we want to save all the work that we have done in our database for our future sessions, right? And to save our work for future sessions, all we have to write is commit. Now, when we execute commit like this, what happens is in the future session, all this work will be saved, right? So all the changes that we did to the student table, all the values that we have inserted under the student table, all of this will be preserved for our future session as well. And finally, the last tip that I want to show you is the clearing the console tip. So basically, if you want to get rid of all this text that you have here, you simply write CL space SCR, that is clear screen. And there, all the content inside the console is now deleted. Oh, and one more thing that I probably forgot to mention when working with primary keys is that there is another syntax that you can use to create primary keys, which is like this. Okay, so whenever you're actually creating the columns, in this case, suppose we have the ID column, which we want to define as the primary key, correct? So we can write down the keywords primary key right after the data type of that column to indicate that this is the column which we want to define as the primary key. So this is just another alternative syntax that we can use to create primary keys. In the future labs, we will be using another syntax which is used to define primary keys on other different kinds of constraints. All right, so look forward to that later. Anyway, as for the different types of tips and tricks, there is another tip that I want to give you guys. So let me just log back in as the test user. Password was PW123. Okay, so we had a table called student, right? So what if you wanted to see the structure of that table? You can simply write DESC, then the name of the table. Okay, so DESC is a keyword, so it doesn't matter whether you write it in uppercase or lowercase. For proper understanding, I'm using uppercase here. There. And when you write it like this, let's see. Let me just full screen this. Yeah. So when you write it like this, you can see that we can see the entire structure of the table. So ID, name, and semester are the three columns that we have here. We have the data types of those columns. Integer is also the same as the number data type, which we will be taking a look at in some future lab. And finally, notice that the ID column has a special value called not null. So remember that the ID column has been specified as a primary key, correct? So one of the special characteristics of primary key columns is that you cannot insert null values inside primary keys. Whenever you insert any entry inside your table, that entry's primary key value must be not null. Okay, it must be something unique. So that's what this not null is basically indicating. And as you can see, for the name and semester column, we don't exactly have the not null thing, right? So which indicates that this too can be null. If you want, you can insert null values for these columns. Okay. So anyway, those were some of the things that I wanted to show you regarding this lab, and hopefully you were able to learn some things. So try to look into these things carefully, because the tasks that you will be doing for this week are closely related to what you have learned in this lab session. Okay, so take care, and I will see you guys later.